Welcome for the brief demonstration of load cell indicator trainer. So this is the main panel, which is a of course indicator as well as a amplifier unit, and there are three potentiometers. One is a fine balance, coarse balance, and the third one on this side, this is the gain. So then there is a second instrument. This is main load cell, and you can see underneath the load cell is attached in a cantilever fashion. From this side you can see it is in cantilever fashion. It is a 200 kg load cell, and this loading arrangement, you can see it is a 50 kg. So mainly you are supposed to load maximum at a 50 kg. As per the commitment, we are giving 10 kg load here. So there are total 10 kg load set, 4 loads, 4 weights of 2 kg, and then 2 weights of 1 kg each. So making it total 10 kg. Now before you switch on, first you have to connect these 4 wires which are coming from the main load cell unit or from the main load cell as per the color code of the wire. So you just ignore the color code of the terminals. You have to think about this wire and this socket. So blue to blue, red to red, yellow to yellow, and black to black. This is the first thing. Then do not keep this gain pot at minimum. You keep it at somewhere in the middle position initially. Then you switch on the unit. Now once you switch on at the first time or at the start of the day, I would say you should not do anything. Just wait for first 5 minutes, or even I would say 5 to 8 minutes for a warm up time. So basically this is having an instrumentation amplifier, so it requires a warm up time. So there may be some drift, that's why we need to wait for first 5 to 8 minutes or 10 minutes maximum. Once that 10 minutes are over, then you are supposed to calibrate it. So first we need to get a zero balance. So right now it is already pre-calibrated or pre-balanced, so it is, I'm getting a 0. You will not get this kind of a 0 initially. So first keep this potentiometer in a middle position, then with the coarse balance, because there will be imbalance much away from 0. So first you need to use a coarse balance potentiometer. Once you are near the 0, like I'm just disturbing this now, I can call this as 3.8 is you are near 0. At that point, leave this potentiometer and start getting the balance with the help of the P1, the first potentiometer, like this, right? 0. Once you get this 0, then apply a load of 2 kg. So when you apply the load of 2 kg, it should be showing 2.0. If it is not showing, then with the help of this pot P3 or the gain potentiometer, adjust very slowly to get a 2.0. So you have to adjust it very gently, carefully. Once you get that 2 for 2 kg, then remove the load and again check that you are getting 0 here. Once you remove the load, again it should be back to 0. If it is not back to 0, slightly away from a 0 or a minus sign is coming, you may adjust this at a 0 exactly, right? So now I can say the calibration is complete. So calibration is complete. Now you can start taking the readings. Now what we have written as a precaution or the procedure here is operate potentiometers carefully. This is a precaution. Then user need to get a 0 balance by adjusting the fine balance pot P1 every 10 minutes after initial calibration. So right now the initial calibration is done. I have calibrated a 0 also, I have got 0 also, as well as the maximum potentiometer or the gain potentiometer we have adjusted, and we can go on taking the readings, right? This is normal procedure. I am adding the load now. So this is a 8 kg, it's showing 8.1 kg, and I will be adding 2 more kgs, right? So this is a 10.1 kg. I am getting 10.1 kg. I added a 10 kg right now. So this equipment is working, testing is over. But if you want to take a readings, suppose even after 15 minutes again, if you want to come, that point of time the 0 might have some drift from a 0. So you may not get exactly 0 whenever you remove the load completely. If that happens after 5 to 10 minutes, then you need to only disturb this pot P1. At that point of time, you are not supposed to disturb these 2 points, because already we have got a balance, already the gain is adjusted as per the load. So what I mean is, now suppose the 10 minutes have passed once I have taken the readings. Now again I want to take the readings. In that case, you remove the load completely. Check first whether I am getting exactly a 0. In that case, if there is some drift from 0, then you only disturb this pot P1. You do not disturb these two pots. If it is right now, it is only 2 or 3 minutes past, so there is no drift, it is showing 0. So in case if it is away from 0, adjust this pot P1 and then you start taking the readings again like this. So again I am putting a 2 kg, I am getting a 2 kg. That's it. So this is how the experiment is to be performed. Then on the back side of this unit, you can see there is a test point which is written as output in millivolts. So that output can be measured with the help of an external multimeter. That output is nothing but, if I am getting a 2 kg here, 2.0, I will be getting 20 millivolts on the back side. So for a 10 kg, I will be getting 100 millivolts on the back side. So that is given for the external measurement. So you can say that is the output of the amplifier. This is the indicated output in kgs, and that is the measured output in millivolts. That is the output of the amplifier. And also, if you want to measure the bridge output, you may able to measure it across these 2 points. Of course, that will be in microvolts or very 1 or 2 millivolts only. So you should have a very good quality multimeter which is having a microvolt measurement. So you also will be able to measure the voltage output from the load cell and